Hi everyone, so in these next few videos we're going to be looking at using C++ with Unreal 4 and also comparing C++ to Blueprint and seeing how they're different and how they can work together. Now, I see here that Unreal 4.21 is out. I'm going to be doing this in 4.20 if I just launch that. The reason is a lot of the students that I teach on a day-to-day basis are using 4.20 because that's what we've got installed at work. So you could use 421 if you really wanted to do this, but a few steps may be different, but it will be largely the same. Right, so I'm going to go with a new project. It's going to be a C++ project rather than Blueprint, and I'm going to base it on the first person template. See, we'll have the starter content. We'll call this something like, it doesn't matter what it's called, my project will do for now. And I'm putting it on my C drive, which is an SSD drive. This, at least on the machine that I'm recording on, is really important. If I try to put this on the D drive, which is an old style spinning disk, compiling takes so long that it may as well you just give up. But my C drive is an SSD, and on that compile times are fast enough that things work. There may be something wrong with my hard drive. So C drive, my project, create project, and we just need to wait while Unreal does two things: builds all the Visual Studio stuff and creates all the C++ files for our character, and also creates the entire Unreal project, and then it will load both Visual Studio and Unreal Engine. While we're waiting for that to happen, I'll just explain what we're going to be doing. This is going to be a really simple example of how C++ and Unreal work together, where we're going to create like a flickering light. So Unreal has built into it point lights, spotlights, all that kind of stuff. We're going to take the point light component and use it to build like a flickering light that we can drop in the level in various places and control how fast the light flickers and what minimum maximum brightness it can have when it does flicker. So we'll do this two ways. We'll do it entirely through C++ first, in terms of all the logic and everything to get that working, and just use Blueprint to lay out the components, because there's going to be the mesh for the light and then the point light component itself. And then we'll do at the end of the video, we'll do exactly the same thing again, but we'll do it entirely in Blueprint without touching C, just so you can see what the differences are. Okay, so here's Visual Studio and Unreal coming up. I don't think it's worth me pausing the video and just skip ahead here, because this is going to be done in a few seconds anyway. Right, there's Unreal loaded. So this, if you've not used the first person template before, I'll just run you through it. We hit play in Unreal, and we've got a simple first person shooter going on, and this is what we can use as a base to work from. So if we just quit back out of this, and what we're going to do now is start adding some C++. So if we go File, New C++ class, and it says, okay, basically what are you inheriting from? If you're familiar with programming, you know what I mean by inheritance. We need to choose something to extend our new class into. So we're going to go with actor. It says here, an actor is any object that can be placed in the world. Our flickering light is going to be something that can be placed in the world, so it's an actor that we want. If you're creating like a new player character, you go with character, and actor components we'll cover in a later video. So for now, actor. We're going to call this flicker light and hit create class. What that will do now is create the CPP and .h, the header file and this code file for us. It will recompile the C++ that is our project now that we've added code to it, and then it should open Visual Studio. Well, Visual Studio is open, but it will open those files in Visual Studio for us so that we can start adding our code. What I hope to do, just while that's building, I'll explain with this little series of videos, is do simple little, here's how you do so-and-so thing in C++ with Unreal. In each of the videos, I may do it both ways, C++ first, then show you the same thing in Blueprint. The reason I want to do both is because I think as developers, it's important not to just pick one thing and stick with it. So you don't want to be one of those people who's like, I only use C++ and that's it, or I only use Blueprint and that's it, or even I only use Unreal Engine and that's it. It's helpful to see how different systems work and how the same thing can be done in these different systems. Okay, so now that compile is finished, we'll go over to Visual Studio. Let me just maximize this. Another thing I should have pointed out at the beginning, I guess, you need Visual Studio 2017 installed for this to work. I don't think 2015 works anymore, not with the version of Unreal Engine we've got here anyway. Okay, so what do we have? We have a standard C++ header file with a few little extra bits that you may not be familiar with because they're specific to Unreal Engine. And then we have the CPP file, which just looks like any standard CPP file you'd have seen anywhere. Right, so to get our flickering light effect to work, we're going to use the point light component that Unreal Engine has built into it. So what we're going to do first of all is just go and add into our header file a U point light component pointer, which we'll just call light. Now this may look a little bit different to how you've got it laid out, because I've got something installed called Visual Assist, which helps out with things like this. So I can just right click on point light component and go add include, and it will just put that in for me. If you don't have Visual Assist installed, then Visual Studio on its own can get a bit tripped up with Unreal's fault and put lots of red squiggles everywhere like this. Even though there's nothing wrong with this generated body, it's saying there is. And like I said, without Visual Assist installed, you get a lot more of that, so just be careful of that. We'll come back to the header file later. So for now, what we've done, we've got a pointer to a point light component, but we haven't actually created that component yet. That's something we need to do in the constructor in the CPP file. So we'll head over there, and in the constructor go light equals, and this is where normally in C++ you go something like light equals new light brackets and then whatever you want to send to lights constructor. Here in Unreal we're going to go and use a built-in function called create default subobject. And create default subobject is like a templated function, so it needs to know in angle brackets what it is you're trying to create, in our case a point light component, and then you pass as a parameter what are you going to call it. So we're just going to call that the light. And we're going to start off with our light off, so or in other words it's going to have an intensity of 0, so we'll go light set intensity to 0. And then what we're going to do here in the tick function, so tick, as it says here, is a function that's called every frame. We're going to roll a random number between 0 and 1, so it's obviously a decimal number, not an integer, a float basically. And if that float is below a certain threshold, we'll switch the light on if it's off, or off if it's on. So basically it will flicker, you'll see. We're not going to be using it in this video, but just so you know, the begin play function, as it says here, gets called when the game starts or when something of this class is spawned. So if there's any initialization or setup you need to do, you do it in your begin play. No, we don't actually need that. Right, now our flickering lights. The logic for getting this to flicker is pretty simple. We're just going to say, first of all, generate a random float between 0 and 1. So we'll use the fmath library that's built into Unreal. Rand range, what was it? Frand range. And we want a number between 0.0 and 1.0. So we're going to, 0.5, 0.25, things like that. Oops, let's get rid of this extra thing where I don't need that. Then what we're going to do is check the value of that. So say if rand float is less than 0.1, what do we want to do? Well, like I said, to get this light to flicker, we're going to say, well, if this is true, if the light was on, switch it off. If it's off, switch it on. Which, if you think about it, this will be true 10% of the time. So, as another if statement, if light intensity is greater than 0, then set intensity to 0, and that should be a capital I there. Light set intensity 0, so that's the light was on, it was intensity was greater than 0, now it's being switched off. Else, so this is the light intensity was 0, we want to switch it back on again, and we'll do this not by setting it to not by just copying this line and putting in some number higher than 0, but we'll roll a random new brightness in the same way that we've rolled a random float here. So what we can do is just go float new brightness equals, and then that same function fmath frand range, and I'm going to put 200 and 2000 in here. Now you'll notice it seems as though at the moment I'm hard coding in things like minimum, maximum brightness, and this chance to switch on or off here, and yeah, for now that's true, but we are going to go and change that so that it can be changed from within the editor, so these will be replaced with variables in a sec. So we've got our new brightness, now we'll go light set intensity to whatever new brightness is, which is going to be some random value between this and this. And that's all we need to do for now in here. So if we switch back over, we'll save this first and also save the header file. Go back over to Unreal and hit this compile button at the top. It will think for a few seconds, well, about half a minute, and then if there's nothing wrong, we haven't made any typos in the code, we'll get compile complete come up here, and then we can test out this new flicker light. Now, as I say, this is much faster when working on an SSD. If you get extremely long compile times, there are utilities and things you can install to speed things up, like Incredibuild or Live++, but for this project, we don't really need to get into detail about what those are. Right, so compile complete. Now notice we're in the content browser at the bottom here, we're in the folder C++ classes, and then the name of your project, and here you've got that Flicker Light class that we just made. If you're not in this folder, you can find it by going to this choose a path thing here, and then you'll find C++ classes my project, or whatever you called your project listed. Okay, so here's our Flicker Light. Let's drag and drop that, say, here against that wall, move it away a little bit, and then hit play. And there you can see that working. So if I try and leave that on the one side of the screen and get Visual Studio on the other, yeah, you can see what's happening. So every tick, so every frame, roll a random number between 0 and 1. If it's less than 0.1, if the light's intensity is greater than 0, set it to 0. Otherwise, roll a new brightness between this number and this number and set that as the brightness. And this happening every frame, that's why we're getting this flickering effect going on. So what we're going to do now is build on that by making it so that these values aren't just hard-coded in, because at the moment, every time we want to change this or these, we would need to edit the CPP file, then recompile the entire thing, which takes time, and there are better ways of handling that. So we'll stop the game running for now, go back to Visual Studio and do that. So what we're going to do, go to the header file and add in 3 float member variables to be the flicker rate and then the min-max brightness. So float flicker rate and float min brightness and float max brightness. Okay, now we should give these some default values, which we'll do in the constructor. So in the CPP file, in the constructor, we'll go flicker rate equals whatever it was. We'll use the same numbers we used down just now. So flicker rate was 0.1, min brightness was 200, max brightness was 2000. And then we'll just substitute out the hard-coded numbers for these variables. So that is now going to be flicker rate, and then this 200 is going to be min brightness, and this is going to be max brightness. Now before we go back over into Unreal, we need to do something in the header file. At the moment, these won't just show up in the Unreal editor for us to do anything with. So if we wanted to change the values, we'd still have to come in here and change these numbers. To get these to show up in the editor, we need to add something called, if I just put a bit of extra space in, a uProperty macro above each of them. What the uProperty macro does is tells the Unreal editor how to deal with this float or whatever it is. We're just going to go, for the now, edit anywhere, comma, blueprint, read write, comma, category equals flicker. And I'll explain more about what these are doing as we move on through the video, but basically we're saying we can edit this value on the default version of this light or any of its instances. That's what edit anywhere is. We can access this variable and read and write to it from blueprint, and then category is just where on the details panel this is going to show up. So you can organize your variables into different categories depending on what they are. We want this above all 3 of these, so I'm just going to duplicate this line by going Control D, then move it down with Alt and down arrow, and then Control D again to duplicate, move down with Alt down arrow. And importantly, these do not need semicolons after them, which some people expect they will do. They don't, so we'll save that. The CPP file is also saved. We'll go back to Unreal now and hit compile. And again, that will take however long, half a minute. Your mileage may vary depending on the PC that you're on. And then we should have it where we can click on this, our flicker light that we dragged into the map, and we can edit those variables from inside Unreal, so we don't need to go back to Visual Studio each time, edit the C++, recompile it, and so on. Right, there we are, compile complete. So click on this light, and there, see, in the flicker category that we made, which is this, we now have those three floats: flicker rate, min brightness, max brightness. So we could change that to be, I don't know, 0.5, so I like the flickers a lot more often, and the brightness minimum could be 10,000, maximum could be 20,000. Hit play. See. And because we had it on edit anywhere, not just edit defaults, we can change those values per light. So if we had multiple of them, they can have different settings. So if we move this one over here a bit, then add another one, drag another flicker light in, put that there, move that away from the wall a little bit. These can each have different values for those floats. So this one can stay with the defaults of 0.1, 200, 2000. This one can have its 0.5, 10,000, 20,000, and they'll both work. See? So, what do we want to do next with this? Well, at the moment, notice how we can't actually see the point light. The point light itself is invisible. It's just like literally a single volumeless point in the air. Well, it doesn't have to be, but in this case it is. Single point where light is coming from. You can do things like change it from being technically just a point to being like a spherical surface that's giving off light, but we don't really need to get into that right now. What would be nice is if we could actually see this, like have a mesh there where the light is. So what we're going to do is add a mesh component to go with our point light component, and then we'll use the blueprint editor to set that mesh and set up the position of the point light relative to the mesh. So I'm going to quit the game for now and delete one of these lights, so I've just got the this one, and then head back over to Visual Studio. Then in the header file, to go with our point light component, we're going to want a U static mesh component pointer, which we'll just call mesh, and we're going to want to include that. So that's going to be hash include components static mesh component. Okay, and just like we did for the point light, we need to actually create this mesh component in the constructor. So over to the CPP file, we'll do it just above where we create the light. We'll go mesh equals, and then exactly the same thing, create default subobject in angle brackets. What is it that we're creating? It's a static mesh component, and what do we want to call it? The mesh. Let's go with, or light mesh, wherever you want that. Now here's the interesting thing. Now that we've got two components, we should set up a hierarchy between them. We should say which one is the root component, and then the other component will be attached to that root component. If we don't do that, Unreal will just pick a component at random, I think it does, and choose that. Now for us it makes sense for the mesh to be the root component, and then the light to be attached to that. So the mesh will be like the fixed point, so the mesh will be wherever we drop this thing in the editor, and the light can be positioned relative to the mesh basically. The way we'll do that is we'll go root component equals mesh, and then we'll go light pointer attached to mesh. Now one thing, this is Unreal 4.20. If you are working in 4.21, I think that the way this function works is a little bit different, or there's a warning saying this is being deprecated, do something else. Just bear that in mind if you're using the later version. Okay, so with that done, let's head back over to Unreal and hit compile. Now the last time I did this, I'm not quite sure why, but something went a bit weird in terms of how my components were positioned. Like my point light and my mesh just weren't staying together, and I had to close Unreal and then relaunch it again from Visual Studio. So just be warned, that may happen in a minute or two. We'll wait for this to compile first, and then we'll see. There we go, compile complete. And what we want to do is set up what mesh we're going to use. Now it occurs to me I've forgotten to do something here, but I'll show you what I mean. If I've still got that selected, if I click on our root component, which is the mesh, excuse me, notice we can't edit any of its properties. We can't say what mesh we want to use, we can't say where it is, or anything about its physics. And the reason is I forgot to put in the header file these U property lines above our components. So we'll go in here, copy that, paste above the mesh, and maybe change that to category components. And then we'll duplicate that line and put it above the light. So we may as well, so we can do things like change the color of the light and so on. Go back over to Unreal, compile, and then you'll see what it says here: native components are editable when declared as U property in C++. So because we didn't do that, we can't edit any of this stuff. Now that we have done, this will all be editable. What we're going to do though is, rather than trying to arrange how our mesh and light are positioned relative to each other just using this panel here, I'm actually going to inherit the whole thing into a blueprint and then do it through there, because then it's just easier to line up components in blueprints. You'll see what I mean in a second. So to do that, in your content browser, just go to the main content folder, right click, say you're creating a new blueprint, and this blueprint is going to be based on our flicker light. So to do that, we need to expand this all classes option, then search for flicker light, select, and then what do you want to call the new blueprint? We'll call this just BP underscore flicker light, and then double click that to open it. Now the reason that I've done that, you'll see in a second. Okay, so here's our mesh as the root component, and then here's our light attached to the root component, which means if we just choose a mesh, so highlight the mesh component, expand mesh over here on the right, expand static mesh, and then we can choose what mesh we want to use. If you included the starter content in your project, you will have something called SM lamp wall. So I'm going to choose that, and then there's that lamp mesh. Now with the mesh as the root component and the light attached to it, we can move the light around and position it relative to the this lamp mesh, which is why I wanted it to be done that way. Ideally, we want this point light to go sort of inside this dish, just below the surface and just not intersecting anything. Now with the grid set up the way it is, snapping every 10 centimeters, we may not be able to do that, so I'm going to have to go up here, turn the grid down to snap size of 1 for now, just move that along and down a bit. So yeah, so exactly, that point light has gone inside this little lamp bowl and is not intersecting anything. If we hit compile on the blueprint now and then save it, we can add that to our level. So let's take the point light component that we had there already, just delete it, or not. I've got the wrong thing selected, haven't I? I'll tell you what, let's go around here and just drag our new blueprint onto that wall there to make sure that's lined up okay. Yep, that's snapped onto the wall. Hit play, and then see what I mean. So using the blueprint editor, we were able to arrange these two components next to each other how we want them, but we added those components in C++. So you can start to see already how Blueprint and C++ can work together. What I like to do is exactly as you've just seen. So if I'm doing something in C++, I'll use that to say what components I've got and how the components are all attached to each other, and what the defaults are and how everything works. But then when it comes to actually arranging the components, I find that a lot easier to do using Blueprint rather than to do this in code. But you could set this up in code if you wanted to. You just have to, in your C++, say that this light has an offset of 8 in X and 26 in Z as we've got it. But like I say, I find that to be much easier to do visually. Okay, now let's talk a little bit more about these. So these edit anywheres. What options do we have here? Well, quite a lot. If you look it up online, there's quite a few things that you can put in between here. What I'll do is I'll just show you the difference between edit anywhere and edit defaults only. So for the mesh, we'll have that as an edit defaults only. What that means is in the Blueprint editor, as we're working, we can choose what the default mesh will be, and that will be the same for all of our lights. Whereas the actual light component itself, because it says edit anywhere, we can change that on individual instances of these lights, or the default for that matter. So let's go back into Unreal, compile, and while we're waiting for that, we will duplicate this, so we'll have another one of these lamps next to it. Oh, by the way, if you don't know, a fast way to duplicate something in Unreal is just hold Alt and then try and move it, and it will move a copy. Another thing, just while we're waiting for that, If you found that something went wrong, and even after you press compile, your point light seems to be absolutely nowhere near this wall thing, just close Unreal, and then from Visual Studio hit run, and it should sort itself out. I kind of expected that error to happen as I was recording this, and it just didn't. I planned to explain it as it happened, and well, I didn't have the error, so I couldn't, I guess. Right, so anyway, here we are. So notice that for each light, we have the point light component here, and we can do things like edit its color. So if we go in light for this one, scroll down to color, maybe turn that red, get rid of this, and then for this one, we'll change its light color to be, I don't know, blue. But notice that we can't change the mesh. That's because the mesh has edit defaults only, whereas the point light has edit anywhere, so we can change it on the individual instances. If we wanted to change the mesh, we'd have to go into here, here, and then change the default mesh, and it would change all of the lights, right? If you wanted to be able to have different lamp meshes per instance, then your mesh component would need to be edit anywhere. Let's see if that's working. Yeah, see. Okay, so that's a nice little bit of C++. It's only a simple thing that we've done, but you can see now how C++ and Unreal work together, and how when you're using C++ with Unreal, there are a few extra things to take into account that you may not be familiar with if you've never done this before, even if you're familiar with C++. But when it comes to the actual programming of the logic of how things work, it is just normal C++ with some built-in functions from Unreal Engine. Right, so now that that's done, what I want to do is basically repeat what we've just done, but don't do it entirely in Blueprint, and that's a useful thing to know how to do. So we'll get that out of the way there, move this one out of the way here. How would we do this completely in Blueprint without any C++? Because sometimes, it's useful to know both. The reason is, some things are just much easier in C++, like things that are quite math heavy or have a lot of loops going on with some quite complicated logic in. That's easier in C++, undoubtedly. And then other things where, if it's just a process where you're just calling functions one after the next, do this, then do this, then do this, then do this, that may be easier in Blueprint. So I want you to understand how to use both. So to do this all again in Blueprint, if we right-click in the content browser, say create a new Blueprint class, it's based on actor, just like our C++ class was, and we're going to call this BP. I'll call it light2. Okay, we double-click that to open it. Now remember, and what I'm going to do here is keep referring back to Visual Studio, but when we did this in Visual Studio, we added our mesh component and point light component, and then set up a hierarchy between them, saying which one was the root, and then the other one was attached to that. The way you do that in Blueprint is just using this add component drop-down. So we'll go add component point light, wherever that is, there. Then we'll go add component again, static mesh, and then to say which one's the root, we just drag and drop over this default scene root, and the other one we attach to it. So now we've got the same setup. Static mesh is the root, point light attached, and then we can do the same thing here. So choose for our static mesh the same lamp mesh, move our point light into position. Looks like this one is very bright. What does it have a brightness of? Right, so it has a brightness of 5000. Now if you remember, when we did this in C++, we started the light off with an intensity of 0. In Blueprint, that's just change that intensity to 0. Also in C++, we had these three float variables, flicker rate, min brightness, max brightness. To add those through Blueprint, you would just use this variables area here. So we go add a variable, we'll call this flicker rate. To change that to be a float variable, we'll just click there. Well, I'm sorry if I went a bit quick through that. If you click on this little coloured box next to a variable, you can choose what type of variable you want it to be. You can also get that by selecting a variable and using this drop down over here. So we've got a float called flicker rate. We'll add another variable called min brightness, and it's automatically a float because when you add a new variable, the new variable automatically is whatever type you added last. So we added a float last, so our next variable will automatically be a float. Add again, max brightness, and the C++ version, remember we set up some default values for these. To set up some default values in Blueprint, what we do is press compile on the Blueprint first, then we can select each of the variables in turn and set its default value over here. So flicker rate can be 0.1, min brightness can be, what was it, 200, and max brightness can be 2000. Alright, good. Okay, so that's the stuff that's going on in the header file and the stuff that's going on in the constructor. But how would we do this in Blueprint? If you've never seen Blueprint before, this may seem a little bit weird, but you basically lay everything out as like a flowchart instead of text like this, and that's where we really start to get into the issue of which system is easier. Some things are just easier as text in C++, and some things are just easier as flowcharts in Blueprint. So what we'll do, we'll do that, and I'll keep referring to Visual Studio and show you which lines correspond to which bits of Blueprint. So to begin with, in Blueprint, go to the Event Graph tab, and notice there you've got your begin play, your tick function, which are basically this, and then we've got an extra one called begin overlap, which we're not going to get into now. It just deals with collisions and overlaps. What we'll do is Windows select begin play and overlap and delete them, because all we're interested in is tick, and we're interested in basically duplicating this exact functionality but in here instead, and so you can see. So what's the first thing we did? We rolled a random float between 0 and 1. So in Blueprint that would be right click, random float. So basically if you right click in Blueprint, you get this like search menu with all the different things that Blueprint can do. So it basically has tons of functions in. If we look for random float, that's this one, and you can see the tooltip says returns a random float between 0 and 1, so we'll have that. And then what's the next thing we did? Check to see if that random float is less than flicker rate. Well, we've got our flicker rate variable over here, but how do we do this check to see if this random float is less than flicker rate? Right, well, if you click and drag away from this green pin on random float, and then say less than, actually was it less than or equal to? It doesn't matter, but float less than float. And then what are we checking here? So here we're checking, is this random float less than 0? That's not what we want. We want to click and drag our flicker rate variable and drop it there. So now we're checking, is this random float less than flicker rate? Another thing you should know, Blueprint is all color coded. So this kind of light green color is floats. This red color here is booleans, so true or false. So this will be sending out a value of true or false depending on whether random float was less than flicker rate. What we can do with that is then add a branch. A branch is basically an if statement. Right, so if we wire that into there, what we're saying here is every tick, roll a random float, check if it's less than flicker rate, and then do one of two different things depending on whether that's true or false. So this would be your C++, the code that goes inside the if statement, and the false would be like the code that goes inside the else. Okay, let's move this all back a bit to get a bit more room. So what did we do next? Well, we said, well, false, nothing. There's no else on this if statement, so we don't need to wire up anything to the false. For the true, we need immediately another if statement, so another branch saying if the light's intensity is greater than 0. Okay, so we'll grab our point light component, drag away from that and do a get intensity, and then we need to compare, is that greater than 0? So we'll type greater than and have a float greater than float there, and then have another branch. Now the shortcut for adding branches, because you do this all the time in Blueprint, is just hold B on the keyboard and click. Wire that up there. Maybe move these down here. Put this here. Okay, perfect. So now we've got this. If light intensity is greater than 0 in C++ is that, in Blueprint it's this. And then what did we do? Well, if true, we set light intensity to 0. If false, we roll the new brightness between min and max and then set the light intensity to that. Okay, so if true, grab our point light, do a set intensity this time, and that will be set to 0, so that's done. And then off the false branch, we want a point light set intensity again. I could have, actually I'll just show you this. Instead of going through all that again, I could have grabbed these two boxes and done a Control-C, Control-V, and then just move those down here. So in this case, we're not just setting intensity to 0, we're doing a random I can spell random float in range. So this will send out a random float between this number and this number. At the moment they're both 0. What we want to do is drag and drop our min brightness here and our max brightness here, and that should be that. So unless I've made any mistakes in there, and I don't think I have, this and this are basically identical. I mean, ignore the super tick thing for the moment. As you may know from C++ experience, this is just calling the equivalent tick function in the class that we inherit from, in this case actor. But so ignoring that, that is how you do it in C++, and that is how you do it in Blueprint, and you just use whichever one you prefer. You're still using the same programming knowledge in either case, basically. So let's test all this. If we compile that blueprint and hit save, we can now drag an instance of our BP light in, just like the these lights, hit play, and there you are. That's working. So that's the exact same thing, once in C++, once in Blueprint. Now one last thing, you will notice that on the C++ ones we expose these floats to the editor, flicker min max brightness, and we don't have that on our Blueprint one. If we want to do that, we go back into the Blueprint, and then notice next to our variables there's this little eye icon, which is closed at the moment. If you make it so that eye is open, then hit compile, there you go, the floats will now show up, but they're in a category called default. If you want to make our own category like we did here, we made a category called flicker. You go into the Blueprint, select one of the variables, then over here on the right in its properties there's this category thing which is set to default at the moment, and then you can just type in anything you want. So if we put flicker, notice now how the flicker rate variable is in this flicker category, and we can just drag and drop min brightness and max brightness in as well. Hit compile on the Blueprint and save it, and there, see, so now these basically are identical. Right, so that was a really quick introduction to C++ and Unreal and how it differs from Blueprint and how the two can work together. Since a lot of the people that I teach on a day-to-day basis are now just taking their first steps into using C++ with Unreal, this will probably end up being a little series with lots of different short videos in. So, you know, here's how you do this thing, here's how you do that thing. This video might be getting a bit long now for something so simple, so I'm going to leave it there, and I'll see you guys next time.